Hi students, welcome back. This is Plus 1 Computer Science and Computer Application Chapter 2 Part 3 video. Before getting into the video, please do subscribe. So in this class you are going to learn number system conversion. How to convert a given decimal to other number system, that is binary, octal and hexadecimal. You are going to learn number system conversion. So let's start with decimal to binary conversion. So today you are going to learn decimal to binary conversion. First of all, let's start with an example, that is 65. Let's consider the 65 as a decimal number. How did you identify this as a decimal number? By looking at the base, that is 10. So 10 is the base of decimal number. So 65 belongs to decimal number. Now you should convert this decimal to binary. So the method used to convert this decimal to binary is repeated division by 2. You have to divide the given decimal number by 2. That also you should repeat the division. This is the method used to convert decimal to binary. So let's start doing this process. Write the given decimal number 65 and draw a straight line to divide the number. You have to divide it by 2. So every single digit I am going to divide it by 2. So 2 3s are 6. And the next digit 2 2s are 4 and the remainder is 1. There it is given 5 and the remainder is 1. So if you are confused with this, let me show you how to do this in a normal division. So 65 divided by 2, we used to divide in this method. 2 3s are 6. Remainder is 0. You will take the next number to down and 5. So 2 2s are 4 and the remainder is 1. So this is what I have written. 32 is written in this place and the remainder, after a long dash we have to write the remainder. So keep doing this method. So then again you have to divide 32 divided by 2. 2 1 is 2, remainder is 1. And you will read this number as 12. So which means 2 6 are 12 and the remainder is 0. So keep doing the same method. Divided by 2. 8 times 16. 2 8s are 16. Remainder is 0. Once again 2 4s are 8 and the remainder is 0. Keep dividing again and again until you get 1. Once again you have to divide it by 2. 2 2s are 4 and the remainder is 0. Again by 2 you have to divide. 2 1 is 2 and the remainder is 0. Until you get this 1, you have to divide. Keep dividing again and again until you get the last value as 1. Now look at the numbers carefully. The last number is the most significant bit and the first remainder is the least significant bit. So now you should write from bottom to top. That is a way to write the number. From bottom to top you have to write. I'll show you the flow how to gather the number from bottom to top. So this is a way to write the number. So let's write the result of 65. 65 is a decimal number which is equivalent to 1 0 0 0 0 0. That is 5 zeros and 1. So it is equal to binary, that is 1 5 zeros and 1. So this is the binary number for the given decimal 65. So let's try it with another example, 218. So let's take 3-digit number 218 base 10. So this is a decimal number. Let's convert this decimal number to binary. So division method, repeated division method we are going to use. So draw the straight line and write the number 218 and we are going to divide it by 2. So 2 1s are 2. So write the number 2 1s are 2 and you can't divide this 1 by 2. So you are going to write 0 there to take 2 digits. So you have to write 0, otherwise your result goes wrong. So write 0 and take 2 digits for division. 2 9s are 18 and the remainder is 0. And divide it once again. 2 5s are 10. You are not going to divide one single digit, you are going to divide two digit. 2 5s are 10 and 2 4s are 8. Remainder is 1. And once again divided by 2. 2 2s are 4 and the remainder is 1. You will read it like 14. So 2 7s are 14 and the remainder is 0. Once again divided by 2. 2 1s are 2 and 2 3s are 6. Remainder is 1. Keep dividing until you get 1. So 2 6 are 12 and the remainder is 1. Once again 2 3s are 6 and the remainder is 0. And finally again divided by 2. 2 1s are 2 and the remainder is 1. So this is how you will divide the number and remainder you will write side by side, and until you get 1 here you have to repeat the division by 2. And for writing the result from bottom to top you have to write. So simply draw the line that is for our reference. You can draw or you can ignore this drawing line. So for decimal 218 the binary equivalent is 1 1 0 1 1 0 1 0. So from bottom to top you should write and finally end up with the base 2. So the next one is decimal to octal conversion. Here 65 is a decimal number and this decimal number we are going to convert to octal number by repeated division by 8. This method. You have to divide the given decimal number by 8. So let's start. 65 we are going to divide it by 8. So 8 8s are 64. So let's write 8 8s are 64. Remainder is 1. And once again you have to divide it by 8. 8 1s are 8 and the remainder is 0. So for the given decimal number 65, the octal value is 101. That is 101. From bottom to top you should write 101. So 101, that is 101 base 8. This is the octal number for the given decimal value. So let's see one more example. Number 70 is the decimal number. You're going to divide it by 8 to get the octal number. 8 8s are 64. And what will be the remainder? Yes, 70 minus 64. The remainder is 6. You have to write the remainder as 6. And divide once again. So divide the number until you get 1. So 8 1s are 8 and the remainder is 0. And write the answer from bottom to top. For given decimal 70, the octal number is 106 base 8. So if you are going to divide a number by 8, up to 7 you will get the remainder value. So for 70, 106 is the octal number. And next let us see decimal to hexadecimal conversion. So decimal number is 31. This decimal number we have to convert to hexadecimal using the method repeated division by 16. Why there is a need to divide by 16? The base of hexadecimal number is 16. So you have to divide the given decimal number by 16 to get hexadecimal number. So let's do it. 16 ones are 16 and the remainder is 15. Yes. So let's check whether it is right or wrong. 16 twos are 32. Yes, it exceeds the given decimal number. So you have to divide it by 1 and the remainder is 15. If you are going to divide a given number by 16, the remainder you will get from 0 to 15. And the answer we will write from bottom to top. And for 31 base 10, the hexadecimal number is, see when we write the hexadecimal, we have to be careful. The remainder, if it is 15, we will represent it as an alphabet. So if you get the remainder as 10, you have to represent it as A, and 11 as B, and 12 as C, and 13 as D, and 14 as E, and 15 as F. And if you get the remainder greater than 9, that is 10 means you have to write it as A. Likewise, 11 means B, 12 means C, 13 means D, 14 means E, and 15 means F. So this you have to write. So instead of 15, we represent that as F. So the answer is 1, and instead of 15, we write F. 1F, the base is 16. Since it is hexadecimal, you should write 16. So when you divide a number by 16, you do get from 0 to 15 as the remainder. If the remainder is 10, then you have to write A. So as you write the remainder, sideways write the alphabet. So alphabets, we have to write A, B, C, D, E, F if the remainder is greater than 9. So here the answer is 1F base 16. So we have completed method 1, that is decimal to binary, repeated division by 2. Decimal to octal, repeated division by 8. Decimal to hexadecimal, it is repeated division by 16. We do have alternate method. We will see in the next class. Decimal to binary, we have another method, that is sum of power of 2. And octal to hexadecimal also we do have another method. So we'll discuss second method in the next class. Thank you.